The main things that we're going to talk about how to find today is going to be the vertical asymptote and the domain. We're going to talk about a few other things as well, the horizontal asymptote and the range, but we'll hit that a little more heavily next class. We're going to talk about 3 different ways to write the domain. Okay, it's the inequality, the interval, which we've talked about before. And then we are also going to talk about set notation, which interval notation is how you're going to see it written. I'm going to show you set notation because the state of Texas says that I have to show you set notation. But really, after today and today's homework, I mean, there's really no reason for you to have to write the same thing, just 3 different ways. Okay. We are going to talk about, again, the vertical asymptote. Here's the definition of it. It's just a vertical line a function gets closer to but never intersects. I talked about it a little bit last class. For the parent function, it's graphed over here in blue. Okay, or now red, but whatever. So, those 2 things are going to kind of go up and down that asymptote, but it's never going to touch it. One thing I want to talk about, since interval notation is how you're going to see me write it, that symbol right there, that is what is called a union sign. And all that does is it represents a gap in the graph. Okay. So finding the vertical asymptote, it's going to be pretty easy because we're going to find the vertical asymptote the exact same way we found excluded values. Alright? So if I had this right here, what would my excluded value be? 7. The only difference now, instead of writing x cannot equal 7, we're going to write the vertical asymptote is x equals 7. But you're going to find it the exact same way we found the excluded values. Okay, so on number 1, I would take 3x plus 2. The numerator has nothing to do with the vertical asymptote. So I'm going to take that, set it equal to 0, subtract 2, divide by 3. I want you to go ahead and find the excluded value for 2 through 7. Go ahead and do 5, 6, and 7 on those. Just write it. Don't write it on the lines. Just write it right below there. Okay? Brianna, what'd you get on 2?
5 or 1/5.
1/5. Catherine, number 3.
4.5.
Jen, number 4.
-2.
Trevor, number 5. Thank you.
Yeah, good job. I did too.
Reese, number 6.
I didn't do 5, 6, or 7.
What would 6 be, though?
6.
Okay. Jessica, number 7. -3. Okay, so hopefully that should be pretty easy. It's the exact same as finding the excluded value.
Wait, what was 6?
Hold on.
What's 6 and 7?
Oh, 6
is 6.
My bad.
Thank you.
Okay. Finding the vertical asymptote, again, it's the same as the excluded value, which we've been doing for the last 2 weeks. Okay, should be pretty easy. So to write the domain, okay, whenever you have these, and don't write this down here, we'll have to write something else, but whenever you have these graphs, okay, so let's say let's say my vertical asymptote is at 3. And then let's say just my horizontal is at 0. Okay, so I have this. I have this. It's going to go from negative infinity to positive infinity, but there's going to be a gap at 3. So whenever you're writing, especially the inequality in the interval form, you're going to write the domain for this and for this. Okay, so you're kind of writing the domain for two different things. So for your inequality, it's going to be all of the x values that are less than 3, and all of the x values, sorry, that should be 2. Let's go off my example down there. And all of the x values that are greater than 2. Okay, if that's where your vertical asymptote is. For your interval, it's going to go from negative infinity to 2. Then you're going to have that union sign. And then it's going to go from 2 to infinity. Alright, so since you're going to see the interval form more often, kind of look back down here at my example. The negative infinity to 3 is representing this part of your graph. The 3 to infinity is that part of your graph. Okay, but you're not going to have a bracket on there because it's not going to be equal to 3. Alright. And then your set notation up above. You're measuring x, that's what that first thing represents. And then it is all the values except negative 2. So that's what that represents. Okay. So, go ahead and write all 3 forms for the next 2. It shouldn't be that hard because everything is the same except instead of 2, you're going to write 6. Instead of 3, 2, you're going to write negative 3 on the last one. Everything else is going to be the same. There's number 6. And there's number 7. Okay, so the error in a table can represent one of two things. Okay. Obviously, it can represent the vertical asymptote, which is what this one would be. Or it could be the x value of a whole, which we will talk about next class. Okay, but I didn't want to tell you that, hey, error means vertical asymptote, and then next class I tell you error means a whole, and then you're sitting there calling me a filthy liar. Okay, so it could represent one of those things, depending on what you put in there, and we'll talk about the whole thing in next class. So the kind of problem that you would see on this, and you don't have to write this down necessarily, Okay, but you may be given a table on a problem.
You spelled it wrong. By the way.
No, I didn't. Like a hole in a circle. Not like WHOLE.
When were we talking about circles? And it's really hot in here.
Alright, so what you may see on this is I don't know. That those numbers aren't going to be right. But if you're given a table and it asks where's the vertical asymptote, look for where it says error. Vertical asymptote would be x equals -1. Those should be gimme problems. Okay? Vertical asymptote. Error. What's the x value? That's the vertical asymptote. Okay? It won't be a problem if that's all you're given and it's asked for the vertical asymptote. That's what you're looking for. Don't overthink it and think, well, is it that or a hole? You wouldn't have enough information to differentiate that. Okay. All right, so let's go to actually graphing. So this is going back to the transformations, what we talked about last class. Okay. So if I have this first one, the middle one, I'm going to go through the parent function. I'm going to talk about how to graph it a little more accurately. So what would my vertical asymptote be for that graph? Someone just whispered it. What would it be? 0. Okay, and I'm going to kind of tell you what to write there. I'm going to zoom in so that you can see exactly how I'm going to graph these. So your vertical asymptote would be x equals 0. Do not write 0, but x equals 0 because it's... So your vertical asymptote is going to be whatever that is. Since we're doing the parent function and all it is x, that means it didn't move left or right at all, so it's on x equals 0. There's also no d value, so that means it didn't move up or down. So your horizontal asymptote is y equals 0. Okay, so down there where it says HA, that's horizontal asymptote, right, y equals 0. So whenever you graph these, okay, so we didn't talk about how to graph this very accurately last time, which we're going to now. If it does not vertically stretch or compress, which is probably going to be the majority of the problems that you'll have, you'll start where the two asymptotes cross, and you're going to go right 1/2, half a unit, up 2. There's a point. Right 1, up 1. Right 2, up 1/2. Those 3 points. Okay, so it's just going to make this little curve right here. Alright. After you do that, to get the other part, you're going to write the points that reflect across that point. So if I want right half a unit up 2, to get the point that's going to reflect from that one, I'm going to go left half a unit down 2. I'm also going to go left 1 down 1. Left 2 down 1/2. Okay, so that's going to give you a much more accurate curve on there. And we'll talk about how we're going to do it when you have a vertical stretch here in a little bit. Okay? Those are really the only 6 points you have to worry about. So there's that. There's that right there. Alright, so to fill in what you got down below, your domain, it goes from -infinity to 0, union, 0 to infinity. On your range, it's a very similar idea, except these zeros are representing the horizontal asymptote. So your domain and your vertical asymptote, you want to kind of think of them as they're paired up. Your horizontal asymptote and your range, which we'll talk about that more next class, those two are always going to go together. Your table, so let's do -2, -1, 0, 1, 2. You'll probably have an extra. I think you'll have an extra column down there. That's fine. So I've got -2, -0.5, -1, -1. What's it going to say on 0? Error. Why? Because that's where the what is? The vertical asymptote. And then I've got 1, +1, 2, +1/2. All right. Questions on graphing that? Okay. Let's go to the one on the left. Casey, what would my vertical asymptote be? Do what? 0. X = 0. So once I have my vertical asymptote, I can write that. I can also write my domain. Grant, what's my horizontal asymptote? No. What's the D value? So which direction is that going to go? Up 5. So y = 5. Remember the C value. The C value moves the vertical left and right. The D value is going to move the horizontal up and down. Once I have the horizontal, I can also write my range. And then I can go put those 6 points in. There you go. I want you to attempt number 10. Hopefully you're able to find at least the vertical asymptote at 2, horizontal at 1, and you're able to write your domain and range. Okay, let's talk about those points. Those 6 points real quick. So, this is the way I graph it. If you move those asymptotes, it's almost like you've taken those, whenever you're graphing and you're actually putting on there, it's almost like you've taken those two things out of the equation, so you don't have to deal with them anymore. Alright? So now you're really only dealing with 1 over x, but you've got to see, if you're doing it this way, it's now almost like that right there is your new origin. Okay? Whoa. no, all my stuff disappeared on here. Okay, so I've got 1 over x. So if I go to the right one, I know that's technically 5, but if I'm looking, this is my new origin. If I go to the right one, that's what I'm going to put up there in x. So, what is 1 over 1? 1. So whatever I put in for x, that's the distance I'm going to the right. Whatever that gives me, 1 over 1 is 1. That's how many units I'm going to go up. So I go right 1, up 1. Okay. If I put 2 in for x, I'm going to go right 2. 1 over 2 is 0.5. So right 2, up 0.5. If I go to the right 1/2, 1 divided by 1/2 is 2. So I'll go right 1/2, up 2. Alright? So all we're putting in for x is the distance that you're going to the right. You can either think of it that way, or you can just remember that's 2. That right there. And those aren't the exact points that you're going to, because all that would be around here. That's the distances you're traveling. Okay? Right 1/2, up 2. Right 1, up 1. Right 2, up 1/2. And then you would just do the other ones reflected across the asymptotes intersection.
I mean, it's so much easier than...
Or you can do that. Alright, so turn over to the back. We're only going to do 3. I think there's like 5 back there. We're only going to do 3 of them. Alright, so whenever you've got 1 over x squared, a lot of the parts of this graph are similar to 1 over x. Your vertical asymptote is x equals 0. Your horizontal asymptote is y equals 0. Your domain is the same. Your range is not going to be the same. Going to the graph, you're still going to have, again, that vertical asymptote, that horizontal asymptote. You're still going to have this part of the graph. Okay, so everything up there is the same as what we did on the other side of this page. The only thing that is different is now, instead of that part of the graph being right there, it is also going to be above the x-axis. Okay? You're not going to see a whole lot of x squared stuff. Okay, it's mostly just going to be over a linear function, but that doesn't mean that this isn't fair game. So your range, because there is nothing below the vertical asymptote, your range is just going to be 0 to infinity. And then your table, let's do the same points that we did on the front. Just fill it in. My table's cut off. Just put it down there. So you got negative 2, 0.5, negative 1, 1, 0. That's your vertical asymptote. So that's where error will be. And then you've got 1, 1, 2.5. Okay. Going over to 12. What would my vertical asymptote be there? Negative 3. All the squared tells you is that now that goes up. Everything else is the same. What is my horizontal asymptote? 0. See if you can finish it from there. Alright, so this is what you should have gotten. Sorry, domain should have 3, not 0 in there. Okay.
So do we not have the whole formula?
Okay, so let's go down and look at 13. Let me zoom into this one real quick. Okay, so on this one, let's get all the basic stuff on here. It doesn't move left or right. It doesn't move up or down. So there is your horizontal asymptote, your vertical asymptote, and then your domain and range. So I'm going to take all the y values and I'm going to multiply them by 2. So I've got, again, all these points right here. My x values will stay the same. One half times 2 is 1. And then 2 times 2 is 4. And so those are going to be the points that I want to graph. And now you could plug in the other points that you would do. So I mean, you could do -1, 1, -2, 1/2, -1/2, 2, and do the same thing. Or on this one, you could just reflect those points across the y-axis. Okay. Now, if this was just 2 over x, which you're much more likely to see that than 2 over x squared. Again, how you would reflect those across the point. If I went 1/2, right 1/2, up 4, I would go left 1/2, down 4. Right 1 up 2, left 1 down 2. Right 2 up 1, left 2 down 1. And that is what I would graph if it was just 2 over x. Okay? So, okay, if you can go to the restroom, you can. Did I talk about the retest being moved? Okay, so.
I don't know when it is.
Oh, okay. You're going to essentially have 6 opportunities to take the retest. Okay, and I'm moving it to next Monday, Tuesday, so that you have the weekend either to try to prepare to not fail it, or you have the weekend to try to prepare to fail it. Whatever you decide is your choice. But you can either take it before school or during advisory in this class, or after school in room D217 on either Monday or Tuesday. Okay, so that's 3 times on Monday, 3 times on Tuesday. You'll need to come in with all of that stuff taken care of. All right, and I'll have those printed out, and you'll staple that to the front of all that and turn it in before you get your retest. Those of you who weren't here was there anyone not here last time? Reese? Okay. Reese, I'll talk to you about all that. Okay. I'm not even sure, I don't know if you did or not, but okay, so that's how we'll do the retest.